Pesa. They're heavily involved in this technology, not only for broadcasters, but for government applications and public safety and all kinds of very interesting applications. So looking forward to his presentation. I do want to mention that all of these presentations are being recorded on video and will be posted to the VSF.TV website and the Video Services Forum YouTube channel. And please get your badge scanned at the front desk, and you'll get some mail that tells you how to download the PDFs of the presentations and all that other good stuff. So we're trying to produce this information, share it with everybody, and provide a resource that all of you can take advantage of. So Scott, you can come on up.
Hello, hello. Thank you, Wes.
All right, Scott, and take it away and tell us how and why this is going to.
Yeah, absolutely, absolutely. Thanks, guys, for having me here. I serve on the AIMS Pro AV committee. I'm the co-chair with David Spinney. I'm sure I pronounced his wrong. He's with Matrox. I'm with Pesa. Andy's from Macnica. We're probably the three most active members on the group, but the interest came from the idea of coming into the 2110 standard and seeing if it could be adopted for Pro AV applications. And so a couple of things have been interesting to me because I served on the 2110 Standards Committee and saw it kind of go from the VSF framework and then on to the actual standard and then publication and so forth. So it's been an interesting road to see an actual standard evolve, but in the same manner that there was a need to coalesce all the broadcast gang together, there's the same exact need for the Pro AV community. And what I mean by that is it takes standards to really make the idea take off. And so why do you do that? It's real simple. It's interoperability. And I mentioned it here 3 times. It's no different. I like Mike Cronk's analogy to the train because at the turn of the centuries and when trains were just coming into themselves, there were different ideas about the widths of gauges. And when they sat down and said, okay, they shall be X, they'll meet the standard and so forth, then train service really kind of took off because they could all use the same rails, but you could use different locomotive engines and different transport vehicles, etc. But it used the same gauge so that we could move the train along, right? In video, it's really no different. We have a transport topology. We can move it along, but there are any number of means that we could do that with. If we all choose a different method to do that with, then it becomes rather problematic. In the AV standards, we've always kind of followed the yellow brick road, so to speak. In other words, we always had standards in the AV industry before. There's really no reason why they wouldn't be used in the future, and I fully expect that there will be a common element, just like HDMI became a common element, just like other things have become a common element, and these coalesce the industries. In analog video, it certainly happened with broadcast, even though there were 3 different variants of that. Early on, there were the American PAL or the American NTSC, never the same color twice. PAL, CCAM, these were all disparate topologies, and then when we moved into digital video, they became kind of the same, although we were able to wrap in different frame rates and slightly different resolutions. Either way, we were able to at least identify what they were and then make the equipment adjust accordingly, so that if you needed to use 50 frame rate or a 60 frame rate, you had the means to do that with under a common standard, and that's where SMPTE came from, right? SMPTE started adopting the 259 standard, the 292 later, and then now 424 for 4K, so forth. So but we have a method, a standard by which we can all look at, see, and then adopt our standard accordingly to move the train down the track again. That's no different in the audio circuits where they first came out of telco and radio with 600 and 150 ohm type impedance, and then later on they were adapted for digital and the AES varieties, and the standards group of AES took over, and we have some fine and wonderful standards that we could use to traverse audio down the same train tracks. So the same thinking is there. But now that we move it onto IP, you'd think we'd be divorced of standards. We're not. Everybody familiar with this model? This model is unbreakable. If you're going to do Ethernet, you got to look at this guy because you ain't going to escape it. The OSI stack has been around for a long, long time. And in fact, when we created the standards for SMPTE 2110, these were clearly in view. In fact, we had to kind of choose the PHY level, the Ethernet in this case, the UDP, the Universal Data Protocol packet. RTP was certainly handy before in transport used for compressed video. It certainly is going to be standard going forward because we have a sequencing and a timestamp technique. So these were all pieces and parts that we pulled out, not out of the air, but out of the standard. This comes from the OSI stack. So it's still a part of us. It's just a matter of which ones. Now, these standards group didn't just get started by willy-nilly, gee, looks good. They were very, very calculated. These are all a process where we get in the room and we kind of get enough people together and we say, okay, we'd like to do it this way and you'd like to do it that way. Can we come to some agreement? And we start to build an RFC. That's certainly the job of the IETF. They're still going strong. In fact, several of our video codecs are going through these processes as we speak. The IEEE has been around forever, and that's where we pulled the PTP timing from. That didn't just exist out of nowhere. That came from standard. The SMPTE, obviously, and I mentioned these standards before, but video was always a standard, and we used the experts in the field, which was the Society of Motion Picture and Television Engineers, which are all very familiar with. They use the 259, the 292, and the other standards that go with it. AES the same way. Now we have a wonderful AES 67 standard, and there's the old AES 3 standard, which we used. And those are all standards that we can all say, okay, as long as we pay attention to the rules, we can use the same train tracks and move the train down the pike. So why is Pro AV avoiding these standards? That's a great question. I don't know why. And I think it has to do with more practicality. Gee, we can build it, it'll work. It just works for our stuff. Great. We don't give a squat about anybody else about this, right? So we can just do it and be done with it, right? Well, there's this part about interoperability. Is anybody really asking the questions in the Pro AV market, or did they give a crap? That's my question, right? People should. Why? You have to move the train down the track. You're going to have different track widths now? Is that suddenly in vogue? I don't think so. And so for the same exact reason, this idea of doing down a proprietary train track is detrimental to everybody. It serves one and one only. That's the whole point behind a proprietary standard. And if that's the way that the market wants to go, that's fine, but there are available standards that we can all adhere to and not really give up our creativity or our flexibility in creating solutions, and this is the whole idea behind creating a standard behind Pro AV. We have actually the framework to do this, and it's not going to cost anything other than to sit down, get some people involved, and shake hands and figure out how we do this. So just a quick review of what the standards are. There's been tons of speakers. I've spoken on this topic for a number of years. I actually went through the whole process of listening to these being actually created during the SMPTE 2110 or the 32 NF60 draft group committee. This is certainly the basis for the standard. The first section involves synchronization and timing. Again, these were 1588 based. The video standard actually got broken into a couple pieces here, but by and large it was an uncompressed effort, and it was loosely based off of 4175 RFC. So again, they kind of looked at it and said, geez, you know, we don't really need all the ANC data, we don't need sync, we don't need all of that. That's covered in the first section. So if we're just dealing with lines and pixels, there's no reason why we can't do that in the 4175. We'll just adapt it for what we can do here, and that's really the shell of 20. There was a bit of contention in the group about timing, in other words, the packet emission. So we broke that out for all of us to kind of sit around and argue and chew on it. And that's the 2110 or 2110-21 timing standard for video. But it has to do with making sure that the packet spaces between the packets are even. So it has to do with packet timing. And obviously, if you can keep it really tight, it's easier for receivers. If they become a little looser, it becomes a little bit more of a problem, and that becomes a buffer issue for a receiver. So we were trying to keep it easy and simple so that we could actually go about that. But again, it came down to the same resolution. We got people in a room, and we said, hey, we got a problem here. What say us all? How do we figure this out? We're smart guys. We can do this. 2110-30 actually got broken up into sections. The uncompressed part was easily adapted from 67. The AES spent a great deal of time making that standard. It was very easy to adapt and just basically suck into 2110-30. 31 is more a derivation of AES 3. We were able to get those pieces and parts in for compressed videos and so forth, or compressed audios, and that worked out quite well. 40 was the 291 standard. This was the chunk that was left over from the ancillary data that was left into the vertical interval, where we left little things like closed caption and at least in the American side. Some used time code, and some other used flags and all sorts of little interesting data goodies, and we could stick them into the vertical interval because underneath the raster here you couldn't see anything, so we stuck in data there. Well, in this format, you don't need to do that. And there are some movements now to, instead of breaking them up into the size of lines, which is what the 291 standard did, in the 41 derivation, we can actually move this out into slightly larger flows for data purposes. Come to mind 232. We could do all sorts of things. And the registration process within SMPTE is fairly straightforward. Of all the entries that have ever been entered into for ANC data, there was only 89 or something. So there's plenty of room for anybody's ideas to stick into 291 and later in 41. Now we did do some outside help with the boys at AMWA. They helped us with the network management piece of this, the NMOS. That's how we take in a flow, or we take in a device on the network wire. We want to know whether it's a transmitter or a receiver or a sender. What have you. We need to give it an address. We need to give it a multicast essence piece. And so there's some very fundamental things you're going to need to do when you introduce a flow to the stream. And this is kind of like the DHCP process for media. We have to be able to tag it and move it on. So that's where the NMOS piece comes from. So all of this is all very good, but what's missing? You know, we have the professional side, which is really very fundamental. It's a very straightforward transport stream. It really mimics a lot of the pieces that were a part of SDI. But in Pro AV, we use all sorts of different things. And so when the committee was first put together for AIMS, we wanted to figure out, like we did at the beginning of AIMS, figure out where the gaps were. And one of the pieces that I felt very strongly about was that the Pro AV community was not really interested in uncompressed video because of the payloads. They're enormous. And so we'd need some sort of a compression piece. So there are several that are registered, and that's how we came about in 2110-22. There is a compression standard for the 2110 suite, and it's quite flexible. We use the pattern of 2042, which is the VC2, the old Dirac codec. We use that one for a basis of being able to identify a very common, free, easy-to-do codec, but there's others coming on that are quite sophisticated, and I call out TicoXS as one. We tend to think that most of these compressed videos that are going to be used in Pro AV will have low latency, and obviously the ones that I think initially will be favored will be the ones that are wavelet-based because of the latency. Most of these are under sub 15 milliseconds and less. The other derivatives could be used, and they're certainly used in various parts and pieces of Pro AV, and some in IT. For example, there are video codecs used as H.264 and H.265 compression schemes for virtual desktop interfaces. So those pieces and parts could be actually moved around and used by Pro AV. But again, they point to a standard. These aren't willy-nilly, oh, gee, let's use our own thing. We'll create this from scratch. These are, by gosh, standards, and they're registered. And so people can look them up and see what the payload properties are and see what the header characteristics are, and they have some clue of how to integrate these pieces and parts together. And that's the point of that one. So For me, video is fairly straightforward. We can register any number of different compression formats, but that doesn't answer the whole problem for Pro AV. So what's the missing link, right? We've identified in the group these kind of subheadings of content protection. Andy gave us a brief overview of some of the pieces that were missing. I didn't include EDID except for the secondary interfacing piece here, but certainly we need something very simplified because generally speaking we take in display type video and it's non-synchronous. So the requirement for Pro AV is vastly different than that of broadcast. I would totally agree with that. So we need to come around with some sort of an application or a subsection of the timing piece where we all can agree on how to do something that's not as sophisticated as or as resource intensive as PTP. Certainly the piece that we're working on in my company, we've adapted USB to these flows. GPI and GPO, those have been common in AV for a long time. Again, they use 232 standards and 422 and 485. Those are all very easy formats, but we need to kind of agree on how we're going to encapsulate them, put them in packets, and move our way through so that, you know, we can interface 232 and 422 together. And if we have some place to point to, we can say, this is what we need to do, then that's how that should work. The EDID is a great standard. It's part of, and CEC is certainly a part of that as well. I didn't mention that one. But these pieces and parts are missing in the 2110 suite. And so they need to be either addressed or at least identified and say, this is how we're going to go about them. We're working very stringently on encryption, my company, so we're taking these video flows and we're encrypting them, but to government standards. So those standards are already very well identified for us. Those are FIPS 140-2 and all of the derivations of the crypto that goes behind those. So those are fairly straightforward. We know exactly what we have to do for that, and the military is quite pointed about how they want to have that encryption complied with and certified. So those pieces and parts are there. There is some initiative within the Ames group and the JTNM to address security, but only on a very cursory level. I don't think it's very involved, but nonetheless, we should all be paying attention to this because we're dealing with a topology that is very, at sometimes, open for things that weren't intended, for want of better description. I'll take these in kind of, I'm not going to go into a hell of a lot of detail here, but you know, we have begun some dialogue with the folks at Intel about having to adapt HDCP 2.2 and using the HDMI interfaces. That's a very common Pro AV. You're not going to avoid that interface. So there needs to be some agreement on how we're going to treat HDCP. And everything basically from 4K and lower is addressed in that piece there. Certainly there's 8K that's extended out to that as well. I don't expect that to be a huge issue other than payload. And those are all pieces and parts that are very important to the Pro AV community. To suggest that they don't have as good a quality is nonsense. The requirement that my military folks need in my equipment extend to 444, 4K 60 frames with extremely high resolution, and they don't want to sacrifice any of that. So, you know, to suggest that it's VGA quality and it's good enough for that, that's nonsense. So these are all pieces and parts that we're going to have to sit down and do. I briefly mentioned this, PTP timing. While it's not trivial, it's certainly not trivial in the broadcast sense. I've done it. You have to pay attention to some basic pieces. It's not so overwhelming it can't be done kind of thing, but it's not trivial by the same token. It needs to be very much easier to do for Pro AV. There are a number of ways to do that. We've come up with a method. We'll be happy to share how we do that. We just need to have that handshook and put into a standard where we can say, hey, that's how we do simplified PTP timing, where we're not switching between HDMI sources like we would as our IP2110 standard, uncompressed. So the use cases are slightly different is the point here, right? For USB, certainly that's one that we've done a lot of. This extends all the way to now the new USB 6, I believe it is. There's a whole bunch of stuff in between, anywhere from 40 gig and Thunderbolt all the way down and lower. And those standards are there. And those standards need to be addressed in terms of AV because that's what they use. So these are other pieces and parts that could be easily adapted and said, you know, this is the method that we're going to use to do that with. Just simple common triggers, contact closures for relays and all sorts of things that we've done with for over these many decades. That's not going away just magically, so we need some method, and there's plenty of them out there that we can point to say, hey, these are easy. 232, same way. 232 is still used. It's a very common communications protocol, and it's still very useful in Pro AV. This one needs to be addressed, and it's not like we can't say, okay, point to this standard, and we can say, okay, that's how you do it. But there's no true encapsulated method to say, you know, this is what we want to all agree on. That's what's missing, right? I briefly touched on security. It's very key to our business because we deal with government and military, so there are various methodologies that doesn't have to be as stringent as FIPS. It could be something else. If so, that would be interesting to have kind of a repository or a registration area where you say, okay, these are the kinds of security that we've identified, this is the methods we could go about using them, and therefore other companies could pick and choose whichever they would like to support, knowing that others will follow and others can actually use the same you know, pieces and parts of that. During our AIMS meeting at the beginning of the show, John Mayette spoke about how we do things, how things get done, all that sort of thing, and it comes down to people getting involved. And really that's the crux of what this organization is about, AIMS in general. That's no different than VSF, that's no different than SMPTE, it's no different than anything I've been involved in over the past 30 years. If you want to do something, you get involved. And that's what we're calling for. We want people to come to us, not that we're the end-all be-all, we're just another player in the ecosystem. But if we can all sit down and agree to something, then it becomes a standard. Now we have a common set of train tracks. Now we have a common train that we want to move down the road. I would encourage anybody who's interested in this sort of thing to not only get involved in our Pro AV group, but to get into the VSF. These are certainly pieces and parts that you could actually get involved in and contribute. And really, that's how it happens. It doesn't happen by saying, yeah, that's a great idea. It happens when somebody says, okay, let's talk about it. Let's talk about it on a whiteboard. Let's start writing this out. Let's see what we can do. That's where it happens. And then we'll coalesce all sorts of interesting people that can help us get to the SMPTE standards and so forth. But essentially, that's how the 2110 standard began. Somebody said, let's get together and figure out how to do it. It started at VSF first, and VSF handed SMPTE the framework. That's how it happened. People really literally took off their VSF hats and put on their SMPTE hats, and they wrote the standard. So it's very possible, and I would encourage anybody who's got any questions to this, send me an email. We thank our wonderful sponsors for having this symposium to be able to express ourselves and so forth. Andy, thanks a million for all your input to this. And if you need to get a hold of me, my telephone number's up there and my email address is there. So thank you very much.
Scott, if I may.
Absolutely.
I'm filling in for Wes, who had to go to another meeting, but let me introduce myself. I'm Jeff Cohen, the chair of the SMPTE New York section. And I want to thank you for sharing with us today the NMOS and ST 2110 roadmap and standards, and good pitch for standards. Thank you very much as a SMPTE member. And we'd like to open up to any questions you may have at this time. Are there any questions? I have the microphone for you if there are any questions. Certainly. Standards questions. No? Okay. In that case, I want to thank you once again. And
thank you
very much for joining us.